Welcome back to part 5 of our RTS series using Entity Component System. I think in the previous videos we covered highlighting and deselecting, so selecting and deselecting, and we kind of covered, even though it wasn't the most optimal, we covered how to use the attachment system and how to integrate with the transform system and how everything gets attached and destroyed and all that. So now I think we can finally get into collision. So right now, if we just do this, they just go right by each other, and that's not really efficient. And like you can see, they both get selected, and we can never deselect them. And now they're completely intertwined. That's no bueno. So let's cover what AABB or axis aligned bounding boxes are. So let's switch over to the Mozilla documentation on axis-aligned bounding boxes. Quick Google search should pull this up. The reason why we do it is it's a quick algorithm to determine if two entities are overlapping or not. I don't really want to make an entire physics system that's highly integrated only for Unity to have theirs and better, and then all this work is for nothing. So we just want something quick and to get us going. So yeah, as I said, it's the quickest algorithm, and basically the downside is that it's a non-rotated box. So if you had, like, let's say a rectangle, and you rotated the rectangle, it would still have it straight up. So might not be the most efficient if you need like really precise physics, but for what we need, it works well. And they have a couple of helper things of how we detect if a point is inside AAB, and if two axis-aligned bounding boxes are colliding. Helpful stuff. All of this is here. I won't cover it. Maybe if people want, we can cover like a physics video, but for now we just know like what the gist of what we're talking about. So let's switch back into Unity, and we're going to make an AABB component. Business as usual. Just make a script like that, and we're going to make a new system, which is AABB movement system. So the reason being is we're not going to do attach for this. This is going to be a part of the unit itself, and so we want this to move it constantly with the position of the unit. So we'll go into what all that means later, but for now, that's the two things we'll make. So let's open Visual Studio. Now that we're in the component, let's just copy and paste from the project directory, so I have to spend time typing. Standard stuff. It's our iComponent data, and we're going to add it to our player unit archetype, so we need to expose it into the editor. And we have two values here, the min and max, and this is a float 3. If you were doing 2D collision, you'd only use a float 2 for the x and y axis. And the reason we only need these two is if we go back to the docs here, and basically if you can look at this box, is if we have a min point, let's say here on the x, y, and z axis, and we had a max point of over here, which is the max in each direction of x, y, z, we can actually map out this entire box based on just those 2 points. It will start to make sense as we get into it. If it doesn't, highly recommend looking at some videos on that. It's kind of good to know how these things interact with each other. But in any case, so now that we have this component, let's instantiate it. And where we're going to instantiate it is actually in our spawner system. So let's go do that. Unit spawner system. And all we're going to do is instantiate this new AAB with the position. And so how I get the min and max is the position is calculated by the center of our cube, and since we know our cube is 1 unit each, to get the min we just minus that value by 0.5, and to get the max we just go 0 plus 0.5, and that's actually how we can calculate. If you're using different values for your units, you might want to do this differently, but so far this is the easiest way to go. And that's pretty much it. So now if we just went and run this, the first click would work, but every subsequent click would not work because, as you can see, we only set the position of max and min to once, and as the unit starts to move, this will not be updated because we're destroying these spawners as we make them. So the next thing we have to do is add the unit movement system so that this constantly moves with our unit. And let's paste it. Okay, so it's a job component system. We want this to be fast, and we just have a movement job that just takes in, so anything that has a axis allied bounding box in a position will basically, which our player units all do, will have this. So for this, we just execute, and all we do is the exact same thing we do in the spawner, but we're constantly running this. So really cheap job. It won't cost anything at all, even at like 1,000,000 units. Well, maybe at 1,000,000, but we won't hit that for our RTS for now. But that's all you need. So now we can start upgrading some of our systems. So the first biggest pain point was this player unit select system. So we have this ugly distance thing that like pretty much has a whole bunch of bugs with it, and now we can actually do some pretty cool stuff with this. So let's first just get rid of that. Actually, before I remove it, we still have some work to do to kind of upgrade some of our systems. The first system is the player input system. So right here is we're raycasting still, and we're storing that position as a mouse position. The problem is that requires there always be something to hit, which means there needs to be a collider in the scene. And as we start making our switch to full ECS, the ground eventually won't be just like a regular mono behavior kind of thing. So we're actually going to get rid of a lot of this stuff over here. So believe it or not, we're actually going to remove all of this. And we're going to just remove the mouse position. And we're actually just going to remove this. And this is all actually our player. Oh, and let's remove this. And this is all our player input is going to contain. Maybe it might contain stuff in the future, but for now, it's just going to contain this. And the reason being is we want to create an array with our mouse position in the job that we want to use it for. So we don't want to just make arrays all of it, for every single player input out there for no reason at all. We only want to do it on systems we actually care about. So that's the first thing. So the second thing, actually, that's probably the first thing. So let's move back into the player unit select system. And for this math, so we're going to want to create an array here and pass it in on our execute thread, on our main thread. So let's go up here. Let's put array public array. And then in here, for our array, we will just do camera main, since we only have one camera, screen point to array, then input mouse position. So we're basically only casting array when this job is running. This is much better than the player input system doing it. So we're gonna leave it like that. Then now we can actually use the array in here. But not yet. We have one last thing to do is we gotta make a physics helper class. This will have all of the math that you saw in the Mozilla documentation. So let's get into here over here real quick, and let's go into utilities, and let's make a physics helper class. I guess we'll just call it RTS physics. If your game has some kind of utilities class or you want to do it a little differently, that's up to you. And for this one, I'm definitely going to paste it because it's a lot of code. Nothing too crazy complicated, but don't want to spend time just writing that. So let's get into here. Let's paste it. Okay, so we actually only have two helper functions here. The first one is a box and array intersection and an intersect of two boxes. And where I got this, as you can see, is from the Mozilla documentation. So if we go here, they have ray versus ray, and they basically just have this. They compare the min and maxes of the X, Y, and Z axis, and that's all I have over here. And for the ray, I actually kind of just Googled and found Tavian Barnes. It's one of the top ones on Google, and I'll have this in the description. He has a great way of intersecting raycasting with AAB's intersection, and it's really fast. I just took it. He has it for X and Y. I just took it to put in the third dimension. But basically what you're doing is, and all this is included in the Unity stuff, so you don't have to worry about like recreating an array or something like that. But basically, you get your x's, you max that, get the min and max of that, then compare it to the y's, and then finally the z's, and then we return that if they intersect. I won't go deep into this. Feel free to put a comment if you want an in-depth description, but his article is really good on explaining why all of this works and things like that, so highly recommend it. Okay, so now we can finally go back to here, and we can pass in, well, let's use our RTS physics, and we're going to intersect with two things, array and a box. So we're going to pass in our array that I wonder if we pass in the box first. So we're going to pass in our, let's do AABB, and then let's do array. And we actually don't have the AABB yet, so let's make it so that there's player input position, and we require an AABB component to go through. And then we'll go here, and so we actually don't need, let's see, player input position. Oh, so we just need to add reference to, we'll call it that. And that's all we actually need to do. And this should just work, and we can actually quickly test and verify that this is happening. So let's go to our archetype, and let's add our box, and let's see if it works. So go open prefab. And we'll just add, and we don't need to worry about setting the min and max because we set that in code, and then we can just press play and see what happens. So if we click it, it works well, but our positions are off, and the reason being is we forgot to reset the mouse position there. So we just have one more system to update, and normally we don't do these kind of big updates, but since we're kind of we kind of had a hack before, then that's the main reason why we need to do this. So in the player unit movement system, we're still using the player input mouse position, which this is pretty much null. So we actually want to reuse the code that we had in the mouse position for now. So get the mouse in position, raycast, and if we hit something, then set the float 3 to our current mouse position. So this is what we used to be doing in the player input, but we're just doing it for the movement system. I don't have a better way to do this. This is one thing I'm struggling a little bit for. There's not really good documentation on how to do this, but if I find a better way, then I will obviously add it to the next one. So let's just do that, mouse position, and then let's just have a public float 3 mouse pos. And all we have to do is just use the mouse position from the thread. And now this should work fine. Okay, so we click here, and that's working good, and we click here, that's working good. Okay, so we are actually back. Whoa, it seems like these guys are going into the floor. So let's set our ground to -1, just for now, so that we can get it working and get everything rendering right. We're not too concerned about that. We can tweak those values later and get them pixel perfect. Okay, great. Now they are going. So now we actually have our AABB working. So we know it's moving with it, because when we select up here, it works and it's not just sticking up there or wherever it was spawned. And and we have array intersection. So this kind of paves the way and sets the framework for us to eventually have these guys not collide with each other, unless that's intentional, but most games it's not. However, that one I actually still haven't done yet. I still have to kind of think about. I might have a video, like a brainstorming video on how I want to. The reason why I'm struggling is I need both entities to calculate. I can't just run a collision system on one entity. I'll have to like pass all the entities in and see if they're colliding with each other. So we'll have to see that. However, as kind of final words, if you have like prefabs already and like you don't have these squares and you're wondering how to do it, just make the box where you would want as small as you can so that the unit can still be hit in certain areas. So that's kind of the definition of a hitbox. I don't think it's worth it to make like an editor and things like that. Unity's probably going to come up to have their collision system ECS backed eventually. This is just to kind of maybe learn some basic physics and that kind of cool stuff. So cool. Hopefully you guys been liking these videos. I think that's all we're going to cover in this video. In the next one, we'll cover, as I said, we'll cover collisions, actual collisions, and then we can actually start getting into combat and some of the cooler stuff now that we have collision working. Because the AABB boxes are kind of the basics, or the basis for a lot of those things. So stay tuned. Hopefully you guys been liking this. Love to hear you guys' feedbacks. I'm thinking of starting a new series where we kind of go over some fun mechanics, non-ECS. I know I've been kind of heavy on ECS. Actually, pretty much majority of my videos are ECS, but thinking of doing some fun mechanics as I used to prototype a lot back in the day, and I kind of want to get back into that. So stay tuned for some cool stuff, and hopefully see you in the next video.